Lightning protection for gasoline stations is a crucial safety measure. The National Fire Protection Association Standard No. 780, or NFPA 780, which is the standard for the installation of lightning protection systems, and the American Petroleum Institute Recommended Practice No. 54, or APIRP 54, which is the recommended practice for lightning protection for natural gas and liquid hydrocarbons production, storage, and distribution facilities, provide detailed guidelines. These standards outline the necessary components and installation practices to minimize the risk of fire or explosion due to lightning strikes. The primary components of a lightning protection system include air terminals, down conductors, grounding electrodes, and bonding systems. Air terminals, often referred to as lightning rods, are strategically placed to intercept lightning strikes. They are typically installed on the highest point of a structure, such as the dispenser canopies in the main building. The placement and spacing of air terminals are critical to ensure comprehensive coverage. Down conductors are heavy gauge wires that provide a low impedance path for the lightning current to flow from the air terminals to the grounding system. These conductors are routed along the exterior of the building, taking the most direct path to ground. Sharp bends and long horizontal runs should be avoided, as they can increase impedance and potentially cause side flashes. Grounding electrodes, such as ground rods or ground plates, are buried in the earth to dissipate the lightning current safely. The number and spacing of grounding electrodes depend on the soil resistivity and the overall size of the protected structure. The goal is to achieve a low resistance connection to the earth. Bonding systems are used to connect all conductive components of the gasoline station to the grounding system. This includes metal piping, electrical conduits, and structural steel. Bonding prevents dangerous voltage differences from developing during a lightning strike, which could lead to arcing and ignition of flammable vapors. In addition to these core components, surge arresters are used to protect sensitive electrical equipment from voltage spikes caused by lightning strikes. Surge arresters are installed at the service entrance and at critical equipment locations to divert excess voltage to ground. Bonding jumpers are also used to connect exposed metal objects to the grounding system, ensuring that all conductive surfaces are at the same potential during a lightning event. There are specific situations where lightning protection may not be required for a gasoline station. Firstly, if the station is located in an area with a low frequency of lightning strikes based on data from the National Lightning Detection Network, or NLDN, lightning protection may not be mandated. Secondly, if all fuel storage tanks and dispensers are located underground, the risk of a direct lightning strike igniting flammable vapors is significantly reduced, potentially negating the need for a dedicated lightning protection system. Thirdly, if the gasoline station is located within a larger building that already has a comprehensive lightning protection system meeting applicable standards, additional protection may not be necessary. However, it is essential to verify that the existing system adequately covers the gasoline station's specific needs. Regarding the components in more detail, air terminals must be made of corrosion-resistant materials such as copper or aluminum. The size and shape of the air terminal are determined by the expected lightning current levels. They must be securely mounted to withstand wind and ice loads. Down conductors also require corrosion-resistant materials like copper or aluminum and need to be sized according to the expected current. The path of the down conductor should be as straight as possible, avoiding sharp bends or loops. The grounding system must have a low resistance to earth, typically less than 25 ohms. Multiple ground rods or a ground grid may be required to achieve this resistance. The size and spacing of the ground rods depend on the soil conditions. Bonding is crucial to equalize the potential between different metal components and prevent side flashes. All metal objects within 6 feet of a lightning protection conductor should be bonded to the grounding system. Surge protection devices should be installed at the main electrical panel and at any sensitive electronic equipment. These devices divert excess voltage to ground, protecting the equipment from damage. Regular inspection and maintenance of the lightning protection system are essential to ensure its continued effectiveness. The system should be inspected annually and after any significant lightning events. Any damaged or corroded components should be replaced promptly. The grounding system should be tested periodically to verify its resistance to earth. Furthermore, API RP54 provides additional guidance on lightning protection for facilities handling natural gas and liquid hydrocarbons. It covers specific requirements for storage tanks, pipelines, and processing equipment. The standard emphasizes the importance of bonding and grounding to prevent static electricity buildup, which can also be a source of ignition. In summary, lightning protection for gasoline stations is a critical safety measure that requires careful planning and installation. Compliance with NFPA 780 and API RP54 ensures that the system is designed and installed to effectively mitigate the risks associated with lightning strikes. While there are specific situations where lightning protection may not be required, a thorough risk assessment should be conducted to determine the appropriate level of protection. Proper grounding and bonding are essential to minimize the risk of fire or explosion. Remember to consult with qualified lightning protection professionals to ensure compliance with all applicable codes and standards. These experts can conduct a thorough site assessment, design a custom lightning protection system, and perform the installation and maintenance to ensure it continues to operate as designed. A well-designed and maintained lightning protection system is a vital investment in the safety of a gasoline station and its surrounding community. Always prioritize safety and adhere to the relevant standards and best practices to minimize the risk of lightning-related incidents. Lightning protection systems are designed to protect structures and people from the dangerous effects of lightning strikes. These systems work by providing a safe path for the lightning current to follow to the ground, minimizing the risk of fire, explosion, and electrical shock. The key components of a lightning protection system are air terminals, down conductors, grounding electrodes, and bonding systems. Air terminals, also known as lightning rods, are installed on the highest points of a structure to intercept lightning strikes. They are typically made of copper or aluminum and are designed to provide a low impedance path for the lightning current. Down conductors are heavy gauge wires that connect the air terminals to the grounding electrodes. They carry the lightning current from the air terminals to the ground, where it can be safely dissipated. Grounding electrodes are buried in the earth and provide a connection to the ground. They are typically made of copper or galvanized steel and are designed to have a low resistance to earth. Bonding systems are used to connect all metal components of a structure to the lightning protection system. This includes metal pipes, electrical conduits, and structural steel. Bonding helps to equalize the potential between different metal components and prevent dangerous voltage differences from developing during a lightning strike. When lightning strikes a building without a lightning protection system, the current can travel through the building's electrical and plumbing systems, causing damage and potentially starting a fire. A lightning protection system provides a safe path for the current to follow, minimizing the risk of damage and injury. The installation of a lightning protection system should be performed by a qualified contractor who is familiar with the applicable codes and standards. The system should be designed to meet the specific needs of the structure and should be inspected regularly to ensure that it is in good working condition. In addition to protecting structures from lightning strikes, lightning protection systems can also protect people from electrical shock. When lightning strikes a building, the current can travel through the ground, creating a voltage gradient. People who are standing near the building can be exposed to this voltage gradient and may experience an electrical shock. A lightning protection system helps to reduce the voltage gradient by providing a low resistance path for the current to follow to the ground. This reduces the risk of electrical shock and helps to keep people safe. Lightning protection systems are an important investment in the safety of structures and people. They can help to prevent fires, explosions, and electrical shocks, and they can provide peace of mind knowing that the building is protected from the dangers of lightning strikes. There are several factors to consider when designing a lightning protection system. Firstly, the size and shape of the structure must be taken into account. Taller and wider structures are more likely to be struck by lightning, and they require more extensive lightning protection systems. Secondly, the location of the structure must be considered. Structures located in areas with high lightning activity require more robust lightning protection systems. Thirdly, the type of construction materials used in the structure must be taken into account. Metal structures are more conductive than non-metal structures, and they require different types of lightning protection systems. Fourthly, the presence of sensitive electronic equipment must be considered. Sensitive electronic equipment can be damaged by lightning strikes, and it may require additional surge protection. There are several different types of lightning protection systems available. The most common type of system is the conventional lightning rod system, which consists of air terminals, down conductors, and grounding electrodes. Other types of systems include surge protection devices, which are designed to protect electronic equipment from voltage surges, and early streamer emission systems, which are designed to attract lightning strikes to the air terminals. The selection of the appropriate type of lightning protection system depends on the specific needs of the structure. It is important to consult with a qualified lightning protection contractor to determine the best type of system for this structure. Regular inspection and maintenance of a lightning protection system are essential to ensure that it is in good working condition. The system should be inspected annually and after any significant lightning events. Damaged or corroded components should be replaced promptly. The grounding system should be tested periodically to verify its resistance to earth. A well-designed and maintained lightning protection system is a vital investment in the safety of a structure and its occupants. The National Fire Protection Association, or NFPA, provides detailed standards for the installation of lightning protection systems. These standards are updated regularly to reflect the latest technology and best practices. It is important to comply with these standards to ensure that the lightning protection system is effective and safe. In addition to the NFPA standards, there may be local codes and regulations that apply to lightning protection systems. It is important to check with the local authorities to determine the applicable requirements. Lightning protection is a crucial aspect of safety for gasoline stations. The information provided offers insights into the requirements and exceptions related to lightning protection for these facilities. It emphasizes the importance of adhering to industry standards such as NFPA 780 and API RP54 to mitigate the risks associated with lightning strikes. The narration highlights the essential components of a lightning protection system, including air terminals, down conductors, grounding electrodes, and bonding systems. It explains their functions and the materials they are typically made of. The text underscores the significance of proper installation and maintenance to ensure the continued effectiveness of the system. The conditions under which lightning protection may not be required are also discussed. This includes situations where the station is located in an area with low lightning frequency, when all fuel storage tanks and dispensers are underground, or when the station is within a building with an existing lightning protection system. However, it is stressed that a thorough risk assessment should be conducted to determine the appropriate level of protection. Regular inspection and maintenance of the lightning protection system are essential to ensure its continued effectiveness. The system should be inspected annually and after any significant lightning events. Any damaged or corroded component should be replaced promptly. The grounding system should be tested periodically to verify its resistance to earth. A well-designed and maintained lightning protection system is a vital investment in the safety of a gasoline station and its surrounding community. Always prioritize safety and adhere to the relevant standards and best practices to minimize the risk of lightning-related incidents. Let's delve a little deeper into some of the key components. Firstly, air terminals. Air terminals, often called lightning rods, are the first point of contact for a lightning strike. Their placement is crucial. They need to be positioned in the highest points of the structure to maximize their ability to intercept a strike. The material they are made of is also important. Copper and aluminum are common choices because of their excellent conductivity and resistance to corrosion. Secondly, consider down conductors. Down conductors act as the pathway for the lightning current to travel from the air terminals to the ground. The gauge of the wire is critical. It needs to be thick enough to handle the immense current of a lightning strike. The routing of the down conductor should be as direct as possible, avoiding sharp bends that could impede the flow of current. Thirdly, the grounding system itself. The grounding system is where the lightning current is safely dissipated into the earth. Ground rods are a common component driven deep into the ground to provide a low resistance connection. The number of ground rods and their spacing depend on the soil conditions. Lower soil resistance means the current can dissipate more easily. Fourthly, bonding. Bonding is the process of connecting all metal components of the structure to the lightning protection system. This is essential to equalize the electrical potential and prevent dangerous sparks. Fifthly, surge protection. Surge protection devices are designed to protect sensitive electronic equipment from voltage spikes caused by lightning strikes. These devices divert the excess voltage to ground, preventing damage to the equipment. These are just a few of the important aspects of lightning protection for gasoline stations. Careful consideration of these factors, along with adherence to industry standards, is crucial for ensuring the safety of these facilities.